Okay, so we're doing the calcmetic evaluating limits analytically, and basically we called it evaluating limits by plug and chug. When we evaluate a limit from an equation, we always want to try to substitute first. If we can plug it into an equation and get a value, and that value matches the left and the right hand side, then it just makes life a lot easier, and it can get us a value very quickly, particularly if you have an equation that we know is what we call a continuous function. It goes on and on and on like this, and it doesn't have a break in it or an asymptote. It doesn't have a jump or something like where you'd have a stop, a hole, and then a point down here, and then something like that. So where you have these jumps like this, where your value here at x equals 0 jumps down here, your value for f of x, then these limits, the limit as x approaches 0 here does not exist. It exists coming from the left-hand side or negative side as whatever this y value is. Coming from this side, it's whatever this y value is. Okay, so again, it works really well when functions are well behaved, as they say on calcmetic. Well behaved. Or what we say, we don't have no hole, jump, or asymptote. And we need to make sure that the left-hand side and the right-hand side agree. For example, up here in this particular graph, we have this curve going like this. No matter where I am on the graph, as x approaches some particular value, say this is 4, and this point is 4, 2, right here, then no matter what happens, as x approaches 4, okay, this y value is approaching 2 over here. And as x approaches 4 from this side, y is approaching 2 as well. So that's why plugging and chugging works really well. Things you can do here, you can make a table of values. Don't be afraid, give it a try. If you're trying to find if you're trying to find a limit, make a table of values. Number 2 thing you can do, sketch the graph. Look at it on Desmos if you're allowed technology. If not, just plug in some points and see if you can get the general behavior of the graph. Or maybe you know the general behavior of the graph. And, for example, I'll do 1a with you down here. So you have y equals x squared minus 7x plus 12. Well, if I just wanted to think about the graph of this thing, it would be x minus 4 times x minus 3, which means I have x-intercepts at 3 and 4, which means the graph of this parabola is going to look like this. It's a parabola. It's continuous. So to find the limit as x approaches 5, I need only plug 5 into this, because there is no odd behavior of this graph. There is nothing odd, nothing weird, nothing strange. It's just a parabola. So because I can plug 5 into here for x, I get 5 squared minus 7 times 5 plus 12, which equals 2. So the limit as x approaches 5 is going to be 2. So this point 5, 2 is on the graph, and if we looked at that coming from either side, it would be approaching 2. And that's it in a nutshell for this particular lesson.